Hello, I'm back with another module for Weather and Climate Data Analytics course, and now we are talking about module 6, which is like the second part of machine learning. Especially, I will talk about like feature engineering. So in this module, I have a problem. No, like the teacher asks us, like to build a model, like random forest model to predict monthly tornado occurrence in, I think in Midwest. I'm not sure, but yeah, it's in these selected states like Illinois, and then Wisconsin, Minnesota, Iowa, Missouri, Indiana, and Michigan. Yeah, this is like for you that not familiar with like United States, so this is like the selected states for this module. So I know maybe like the full code for the Jupyter notebook that I built, maybe it will be on private mode since it's like a part of assignment. So yeah, I will try my best to explain you guys like what I already did in the notebooks. So the first one, the problem one, is like we need to aggregate the tornado history data. So the tornado is not is the history data, especially like the updated one. You can access it by clicking this one, like from SPC. It's like available in NOAA website, especially in the storm prediction center, and it's up to date until 2021, I think, because 2022 is still ongoing, so maybe it will be available next year. Yeah, apparently like 2022 it will end like soon in a couple of weeks. So yeah, just like get a new data in the next year, like yeah. So for the history data, yeah, I just like select the states that the teacher asks me by just like log. I just like log and for these states. And then because yeah, the thing that actually I was very confused at the first time, like I literally spent like 2 days just to understand the data, and then I just like figure out that every single row in the data actually it's like the report of the tornado. So to have like an aggregate of monthly prediction, like monthly tornado, you can just like do group by, yeah, just like do group by, and then and resample based on month, on date. And here actually I have like I made like a new code to have a unique value of the depth of the tornado occurrence, and then I count it. Yeah, actually the tornado is like the monthly and the sum counted tornado based on this unique value. Actually, like I did like a trick just like to have easy way to get a new to get a counted tornado. And then yeah, after that I create like new data frame. It's just like you can find in the Stack Overflow, and here like the data frame that I created. And then yeah, because actually for the second problem I need to have like combine or like merge to both data frame of like counter tornado and also like the index like ENSO, PDO, AO, and NAO. And actually I already know the index because it's already appeared in like the fourth module if you can access it. So to have like a same format, so I just like make manipulation for my tornado data frame. So in here I have like 3 column of year, month, and count tornado. And after that, the second one is just to merge. But if you don't know, actually this index is updated every month. So for 2020, there are like two missing months. Yeah, it is like November and December, because it's just running. Yeah. So, and the her, yeah, it's like the looks like the appearance of the original, and so month in the column, and then the year in a row. But because I want to merge both data frame, then I do like manipulate with like some transport and something like that. That's why I build like a function, right, like small function, and then yeah, voila, this is like the final result of my index data frame. And then the one that maybe you should what is like, no, you should consider, because in this module we talk a lot about feature engineering. Oh yeah, for you guys who don't know feature engineering, so feature engineering is actually a way to like prepare our features for, yeah, to work properly in our model. There are two main goals actually for feature engineering. Like the first one is, yeah, of course, like to prepare data set so it can be compatible with machine learning models that you will build. Yeah, and then the second one is like to improve the performance of machine learning models. Maybe I already said in my previous video about machine learning that actually talking about machine learning, the most consumed timing is like for data preparation. I already like read an article, and then it also said like 80% of building machine learning is just like for data preparation. Like, yeah, you need to do like ADA, like data analysis and something like that, and then make sure that you have like a proper and compatible data and something like that. So in here, fortunately my data was not that bad. So I just want to know like the type of the data, and then how much the number, and what kind of method that I can use to handle or to prepare the data. So here for the first data frame, I have like three column or three features, three column, because one of them is like target, the tornado, the content tornado, and everything is like it's really well, it's really fit. I mean, like, you don't have a missing value because everything is non-null, and then the type is like an integer. So yeah, apparently it's like perfect data. And then the second data frame, yeah, you can see everything is perfect, at least for the month column, because the type is not integer but it's like in object. So yeah, even though I know like a month here is like ordinal number and have no special meaning, but yeah, I just still want to have them as a integer, yeah, integer type. And here you can see like there are like there is 24, I think, yeah, 24 missing value. So here we need to do feature engineering, yeah, especially for imputation value, because sometimes not all missing value have to be dropped. So you can still like do a trick or like handle missing value by doing like statistics, like put mean, median, or modes, or like the end of the what is it, distribution, or like, yeah, everything. You can also apply machine learning actually to fill out the missing value, like regression, k neighborhood, or something like that. But here actually I want to do it, but yeah, it doesn't make sense for me to replace the missing value, because if I merge two data frames here, you can see that the least number of the least number of data in the data frame is like 864, which is called tornado, like the reported one, the observed one. So it doesn't make sense, right? If I want to have like 900 data by filling out this content tornado, because this is like something that I want to predict, but I did manipulation before, so it doesn't make sense. That's why I just merge it, merge this two data frame, and then yeah, by using this list data. So here, yeah, just merge it, and voila, everything go well. I mean, like the index data frame follow the content tornado, so it now I have like data frame with 864 rows and 7 columns of year, month, and so PDO, and now AO and content tornado. Yeah, so you can also like read here, but I'm not sure you can find this notebook because it's private. So yeah, actually, yeah, like I said before, we don't have to remove rows containing missing value, as we can do handle it, because like for some cases, like if we drop missing values, we might like lose important data or important information. So yes, we can just handle it by imputation, by feature engineering of imputation value. And then after that, I create a random forest model to predict counted tornado using 4 indices. Yeah, I just like use randomized search CV, because yeah, grid search is just like it's too much for me. Like yeah, my computer is really didn't have, was not happy at all, because it consumed like a lot of time. So yeah, I just use random size search CV here. And then for the feature, I use year, month, and then 4 indices. And then for the target, of course, I use counted tornado, and then I split data by ratio 70 and 30. And this is like the list hyperparameter for, yeah, it's like, yeah, the option for each hyperparameter that I use. And then yeah, as usually, I built like the model and then feed to the data train. So here, like for my computer, this is like my M1, I think. Yeah, MacBook Air M1. It needs like 4 minutes to train like only 864 data with this hyperparameter. And yeah, I got it, like this is like a best parameter, best score, like yeah, best hyperparameter for the best score model. But yeah, you can see actually the accuracy is not good, like it's very low, like only 0.35. That's why when I use the train data, yeah, voila, the coefficient correlation is not that higher, it's only like 0.5. And then the RMSE is like 19 occurrence. So yeah, it's not that the model is not good, I think. I mean, like I don't yeah, I'm satisfied, I was satisfied, but yeah, just edits. And then because I know that feature engineering also can be used for like improve the model, I perform a one-hot encoding for the month of the year, because it's also part of the problem. So what is one-hot encoding? So one-hot encoding actually like a way to split the value in a column to multiple flag column and assign as a binary number 0 or 1. So in here, I have an ordinal number for month that I said before. It has no special meaning, so I transform them into like different column by 12 months, and yeah, by like 1 and 0. And this method help to change categorical or numerical that has ordinal type like month in my case. And this feature is called one-hot-encoding because like it's related to binary number. If you have like an distinct value, for example in this column we can map them to and minus 1 binary column, as the missing value can be deducted from other columns. So if all the column are equal to 0, the missing value is of course 1, right? That's why it's called one-hot encoding. So it's just like a brief explanation about the feature engineering that I use here. And then because I have a new data set, that's why I name it as like OHE or OHE, whatever you called it, and then train it. Voila, I got like new new model with best score here. Like now the number of estimators it's like 1600, and but the best score is not that improved. I mean like it's still 0.35 the accuracy, but just use it, and then I fit with my train data, and then I compare it with the previous data set. You can see that actually this is R is not R square. I will improve it. I will improve it in my script, but not in this video. And the RMSE just like decreased to 18, but not that much. And then the coefficient correlation is like 0.57. It's not that much. But here you can see the interesting part is like we just transform and use applying the one-hot encoding, but the distribution or like the scatter plot is like different, even though the coefficient correlation and RMS is not improved much. But you can see like the scatter plot is like it's really different here. And then to know what happened here, I perform like XAI, explainable AI, and then first I perform a feature importance and multipass permutation analysis of the features. And here actually there are like the new method for the permutation importance. It's from like McGovern about like backward multipass permutation, but unfortunately I failed like many times to apply this one, and then I just used like the basic one about like scalar inspection. And then I try with and repeats 50 because my teacher said that if it's more than 0 it can be called like multipass, even though I'm not sure about that. And here I can see like the top feature importance for the plain data is like month, and then the top feature importance for the new OHE data is like June. Actually the permutation importance works by the decrease in the model performance, and in here I calculated based on like mean error, like mean error, and then also the standard deviation. So we can see that in here if we so from the model loss the month like contribute to like 0.523, and almost like a half of the model loss. That's why it can be said that month is the top feature importance for the plain data. And then after we applied one-hot encoding, now a month of June is like the top feature importance. And then I create another analysis of SHAP. It's like it stands for like Shapley additive explanation, and it's method based on Lundberg and Lee 2017. But here I warn you guys that you must be have like the last updated version of SHAP. In here like I use 0.49 because for some devices it's based on my friends and my classmate comments like, yeah, if you have like different or like the older version, it will leads you to error when plotting some shape figures. So here I use like the updated version and then calculate the SHAP with the basic one. It like explain it. Actually there are different, if I'm not mistaken, there are different shape like kernel shape, tree shape, and here I use like the basic one is like explainer. And then yeah, for you who doesn't know about shape, about SHP or like shape, yeah, if I can say, it's like method to explain individual predictors based on the game theory. So the difference about the shape feature importance and the one that I used before, like permutation important, is shape actually calculate magnitude of feature attributes. So it has like local accuracy, it has like missingness, and then also have consistency. So it's like combination of three attributes. And then the value, if we um, interpret it, so if it's closer to zero, it means that it has the feature has little contributions. If it's like away from zero, and then it's, yeah, it can be said that it's more variations, so yeah, it contributes more to the model. So here I calculate the shape for the two model, like for the plane and then for the OHE. You can see here like why it's like consistent with permutation importance, because the feature of month here have like more variance, and that's why it can be said like the top feature, the top feature importance in this model. And here you can see like June actually has like more spread value than others. Here, yeah, you can see. And then if I can say like here this color represent like the actual value of the feature, and then how they are contributing to the model prediction. So if I can interpret here, if I'm not mistaken, please understand me. So here like for June, we can say that the higher value of June, of course one, because it like one-hot-encoding, so the higher value of June, it contributes to the tornado occurrence. But actually I don't really familiar with like the weather system in United States. I mean, like I know ENSO, but I don't know the other index. If it's Indonesia, ENSO means like a dry season, because most of the moisture will be transport to United States, and then not only United States, like most of part American. So yeah, in Indonesia it will be dry, and yeah, it's like the reverse the reverse event for United States. But for the other index, I don't know. And here I also don't know like the season here. I only know that they have like 4 seasons, but for June apparently it's like the beginning of summer season. But yeah, we can say that the tornado is like mostly occurrence in the June, which is like summer season. Yeah, it may be true, because in summer we have a lot of like heat transport, because we have a lot of like radiation, and maybe it leads to like some convection. So yeah, but I'm not sure with the moisture available in here. We can say that yeah, June is like the most important feature for the second data frame. And then the teacher also asks us to have like feature dependence for ENSO, and here I also cannot say anything more because I don't really familiar with like weather system in United States. So here we can see that like for the plain data, ENSO mostly depend on year, but for applied one-hot encoding, it depends on the June. Even though I don't know like the relationship between ENSO and June. Actually, ENSO is, if I can say, it's like what is like repetitive events with unknown if I can say like unknown period. I know the maximum is 7 years, but it could be like less than that. But here I also like don't really know the physical meaning behind this. But here what I can say, like the conclusion, feature engineering helps to handle or prepare data and also for this case improve the model, even though it's not that much. So yeah, as you can see, before applying OHE, the feature of month was the most important feature, but physically speaking, the month itself has seasonal variations related to the contact tornado. After applying OHE and drop the month feature, it looks like the model learned something new, in which now the most important feature was June, even though I said that I'm not really sure the relationship between tornadoes occurrence with June. And then the second one, the XAI, and yeah, the application of XAI understand help me to understand the model behavior from the feature importance score. So performing permutation important, and also SHAP analysis give me a bit better understanding of why June could be the most important feature, as we can see that both June and May has relatively large variation than others. We can also see that shape values for June and May getting higher with high encoding. And then the third one, of course, helps to know why the model have low accuracy, because the index used as a feature data were not good predictors for tornado occurrence, even though they are really independent to like a target data. But here, if I can say, ENSO index is not good predictor for tornado occurrence, both for plain data and after applying OHE. But from dependence plot, we can see that plain data, for the plain data, the contribution of ENSO to predict tornado mostly influenced by year, and after applying OHE, the contribution of ENSO index to predict tornado depends on June. Still, I'm not sure, but here we can see that the extreme ENSO index has a large variation and higher value for June. Overall, I can see that the provided indexes and other features used here were not a good predictor for the selected states. Actually, it's good because physically speaking, ENSO index does contributing to the water vapor transport to the country, like I said before, but tornado is another event that needs special environment to develop, like strong helicity, vorticity, and so on. So yeah, for from the point of view of machine learning, actually the applying feature engineering, feature importance, SHAP analysis, it helps the modeler to understand like the performance of the model. But as meteorologist, I'm not sure about this. Yeah, because first one, I'm not familiar with the system here, and then the second one, like I'm quite new with the SHAP, so I'm not sure if I interpret the SHAP analysis right. So here like my notebooks. Good luck and happy sharing. More webpage reference can be found here, but I'm not sure you can open this GitHub, but I hope it will be opened once the semester ends. So yeah, thank you guys for listening to me, and I hope this like useful for you. Thanks, bye, and have a good day. Bye.